Hello, welcome to today's session of our series, and we are going to talk about sets. So, this is what we are going to talk about today. Sets. Sets is from the Latin word assam, which means irrational. Irrational. So to have a number to be irrational, we can term it as a set. So let's say, for instance, you can have root 2. Root 2 is irrational. For instance, it gives you 1.414 continuous. So such a number can be termed as irrational. So a number without a root sign can be called a set. Examples of such sets are, for instance, you can have root 3, but having root 9 cannot be a set. Root 9, for instance, is supposed to give you a definite answer, 3. So something like this cannot be a set. And we have two types of them. We have the pure sets and a mixed set. A pure set can be termed as pure if only the part of the set consists of only the irrational part. For instance, you can have this to be a pure set, and we have mixed sets too, and that can be mixed set. For instance, you have 3 root 3. This is the rational part of it, and the root 3 can be called the irrational part. So this instance we have a mixed set. And when it comes to sets, we have some basic rules you must be able to follow. And let's take a look at such rules, since we are certain with what sets are. If you have root 2, for instance, root 2 plus, let's use alphabets to clarify what we cannot do in the rules before we go to an example. If you have root A plus root B, it cannot be equal to the root of the sum. It cannot be equal to this. But then, should you have root A minus root B, for instance, that too cannot be equal to something like this. It cannot be something like this. But should you have root A multiplied by root B, using this multiplication sign, that will give you this root of A times B. This is correct. Should you also have the division sign, root A divided by root B, you can have that as root of A divided by root of B, and that is supposed to give you a square root of A over B. So these are the basic rules we'll be working with if we should consider sets. So you have to familiarize yourself with set things as we are going to take ourselves through some examples. So I'm going to clean this. I don't have enough space on my board, so sorry for the inconvenience. If you can refer. So should we have root 2 plus root 3? This is supposed to give you root 2 plus root 3. This is the simplification form of it. You can't add them because they have different roots. For instance, if let's take it as you have x and y, you can't add them because they are two different variables you can add. It's the same situation applied over here. But let's look at the situation where we have the same roots or the same number under the roots. Let's say we have 4 root 5 plus 3 root 5. If you look at this example, for instance, we have, it's a mixed set. We have the irrational parts to be the same, so we can add all the rational parts and maintain one part of the irrational. For instance, you can say if we have, for instance, 4x plus 3x, this will simply give you a 7x. But if you come to this situation as this plus this, which is 3 plus 4, which is 7, and this x can be in terms of any of these r root 5. So this is the small arithmetic of sets. We are going to go, or we are going to talk about something we call the conjugate of a set. The conjugate of a set. Wow. To talk about conjugates, it's a term that is used to multiply a set to rationally make it not a set again. Let's take an example. If we are asked to simplify, for instance, root 2 over, let's say, 2 plus root 3. We are going to rationalize this, and the best way to do this is to conjugate what we have over here. So we are going to multiply this by 2 minus root 3 over 2 minus root 3. And you simplify this to get the answer. So this is what we call the conjugate. So the conjugate of 2 plus root 3 is 2 minus root 3. Let's go, we'll simplify something like this furthermore, but let's look at more or an example of the rationalizing of sets again. Should you have something like root 2 over root 3? We have root 2 over root 3. We have to rationalize this before we move on to anything, any simplification we have to do. So for instance, we multiply this by root 3 over root 3. And this is supposed to give us what? This times this, which is root 2 times root 3. From the laws, we know we can multiply them. So that will give us root of 6, because 2 times 3 is equal to 6. And we have root 3 multiplied by root 3. That will give us a 3. But before we continue, I'd like to chip in something before we move on. Should you have a root, let's say you have a variable and you have a root of it, of let's say n. This is supposed to give you, let's say you are writing it in the exponent form, it's supposed to give you x exponent 1 over n. Should you have another variable, for instance root y, and you're finding the nth root of it, and there is, let's say for instance, an exponent of it, the inside one is supposed to give you your y, and this is 1 over what? The root of it, which is n, times the exponent we have, which is m. So this is supposed to give you y exponent m over n. Let's take some small example and see how we can deal with something like this. If you have root 2, if you have root 2, it means there is a 2 over here, but the 2 is always hidden. So this is supposed to give me 2 exponent 1 over 2 in terms of the exponential form. So if you have any complicated situation, you can always work your way out. So this will give me 3, 1/3. So you can always solve situations like this. Let's take another look at some basic thing in sets which we'd have to get a better understanding of. Let's say you're given a very big set to simplify. As we said, for instance, root 9 is equal to 3. It has given you a rational number, and this is not a set. But should you have root 2, which gave us 1.414, this was an irrational number, and we know it to be a set, and this is not a set. So should we be given a big number to simplify? For instance, we have root 50. You can't at a go conclude this to be a set or not a set unless you put it in its simplest form. And we know if we should use the factor tree, we know 50 is supposed to give us 25 and 2. So 25 and 2 multiplied will give us the 50 we are looking for. So this, for instance, will give us root 25 multiplied by 2, which is the same as root 25 multiplied by root 2, because when we are studying the laws, we said root a multiplied by root b will be the same as a and b multiplying each other all on the same root sign. So, but root 25 in this case is supposed to give us a 5, as we saw in this case, root of 9 giving us 3. So this is supposed to give us 5 times root of 2. So this, for instance, is 5 root 2. So if you are supposed to simplify root 50, this is your simplification. Let's take another example of this form. Should we be asked, for instance, to find roots of 18 or simplify something like this? We know 18 from the factor 3 is 9 and 2. So this can give me roots of 9 multiplied by roots of 2. But we know root of 9 to be 3, and this will come and apply this to give us root 2. This is what we have if we are asked to simplify sets. So let's look at the square of sets. For instance, mixed sets. That will be very important to take a notification of. Should we have variable x plus variable y, all exponents 2, for instance, it is equal to the first variable squared, which is in this case s squared, plus the second variable squared, which is in this case y squared, plus the exponents times this, which is the first variable, and also times the second variable. So this will give us plus 2xy. So we are going to use this idea to use it to solve for a set situation. So should we be asked to find 2 plus root 3 all squared? We know that we have to square the first, which is 2. So 2 squared plus the second one squared, as in this case 2, which is root 3 squared, plus 2, which was this, and in this case it's also 2, multiply by x, and this is our x, which is 2. Again, multiplied by y, and in this case, our y is root 3. So, should we simplify this further? This will give you a 4. 2 squared is 4. And this will give you a 3. Should you have root 3? This 2. This is usually 2. Should you not have anything over there, and you're having the square of it, this will take away this, leaving our 3. Plus 3. Again, plus this time this is 4. And 4 times root 3 will give us 4 root 3. So we have the real parts and the non-real parts, or the irrational parts. For this is separated, so 4 plus 3 will give us a 7. Plus this, which is the set. And in this case, it is a mixed set after understanding the type of sets we have. So, for instance, if you have a situation like this, you have to simplify. This is how you have to go about it. So, let's go to something further from this. So, should we have, let's take an example. Should we have 1 over 3 plus root 2, and we are asked to simplify. So if you look at this situation, we have the denominator as 3 plus root 2. We have a real part and we have what? The non-real part. So if you have to simplify this, we know what we have to do. What we have to do is rationalize this term. And to rationalize this, we use the conjugate of the denominator. And the conjugate of 3 plus root 2 is what? 3, let me not use equal sign, is 3 minus root 2. That is the conjugate. So, should we have 1 plus 3, 1 over, we have to rationalize this, and this is the same as multiplying by the conjugate over the conjugate. The reason why we multiply the conjugate of over the conjugate is, for instance, should you have 4 and you multiply this 4 by, let's say, 2, and you divide by 2, this will take away this, and in this case it's the same as what? Having 4 times 1, which is equal to 4, which is the same thing. So we are going to do this and do this. So if we should have this and this, the numerator will multiply the numerator, this will take this, and the whole of this will also take the whole of this. So let's go ahead and do. So 1 times the whole of this will give me the same thing, which is 3 minus root 2. All on this time this, we multiply the first term by everything we have here, and the second term by everything we have here. After that, we simplify. So we have 3 times 3, which is 9 in this case, and 3 times minus root 2, and this will give us minus 3 root 2, and we have root 2 multiplied by 3 again, which will give us plus 3 root 2. Let's extend this, and we have root 2 multiplied by root 2, and in this case we have a negative sign over here, so that will give us a negative 2. So we can simplify the denominator to match with the numerator. So let's go ahead. Let me clean this. can break this. So we maintain our numerator because we don't have any simplification to do over here. So this will be 3 minus root 2 over. The real part will go with the real parts, and the non-real or the irrational part will also go with the irrational part. So we have a 9 over here as a real number, and these 2 as a real number. So 9 minus 2 would give me a 7. And this and that 2 will give me a 0, because it's minus 3 root 2 plus 3 root 2. It will take away everything. So our final solution is supposed to be 3 minus root 2 over 7. So this is what we call simplification of such a set. What we did was, after maintaining the set, we rationalized it by multiplying by the conjugates of the denominator. And the conjugate in this sense is supposed to be 3 minus root 2. So we have that over here and that over here too. This can take away this, we maintaining this. So this 1 times the whole of this is what we have over here. And 3 times 3 is the 9 we have on here. 3 times minus root 2 is what we have over here. Plus 2 times root 2 times 3, which is 3 root 2. And root 2 multiplied by minus root 2, which is minus 2. So we simplified our denominator, we maintained our numerator, which we have over here. And 9 minus 2 is the 7 we have over here. And we have minus 3 root 2 plus 3 root 2. That will give us a 0. So plus a 0 over here. And this is what we have. So this is what sets is always about, basically. So should you watch this video, I believe you'll be able to go through everything. And this was brought to you by Gilbert. Thank you.